let's say we want to take a point and rotate it a certain amount of degrees that's not 90, 180, 270, not a multiple of 90 degrees. So this is where geometry is awesome and it's all going to connect and it's just absolutely the best. Okay, let's say we're going to take point A, which is at 5, 0. So this graph doesn't have to be super accurate. I'm not even going to put tick marks. I'm just going to put, here's point A at 5, 0. So let's envision, like we are rotating, envision like I'm going to take a piece of string and hold one end down at the center and one end down at the point, and I'm going to swing it around and rotate. So I just created a circle, and this is a really janky circle, but if I was making a perfect circle, the distance from the center, because I'm rotating about the origin, the distance from the center of my circle, the distance from the origin to my point, that would be like the radius of my circle. So I am rotating this 50 degrees counterclockwise, so this direction, so I'm rotating it 50 degrees counterclockwise. So a little bit more than halfway, because if I was going to rotate it all the way to the y-axis, that would be 90 degrees. So if I was going to rotate it all the way, that would be 90 degrees. So I'm going to rotate it 50 degrees. So this angle right here is 50 degrees. So I'm trying to figure out what are the x and y coordinates of this point. So I know that if I'm starting at the origin, I'm going to go a certain direction to the right, and then I'm going to go a certain amount up. So this amount that I've gone left or right, that's my x direction. So this is my value of x. And then I'm going a certain amount up or down. That's going to be my y value. So I have just created my favorite shape. I just created a right triangle, and I'm going to try and find the lengths of the legs of this right triangle, because if I know this leg, that's my x coordinate, and if I know this leg, that's my y coordinate. Well, we just talked about, like, I'm creating a circle by swinging that point around the origin, and the radius of my circle never changes length. So the radius of my circle is 5 here, so it's going to be 5 over here, because I just took that point and swung it. So I have this right triangle right here, and I can use SOHCAHTOA. So I have my adjacent side, my opposite side, and I have my hypotenuse. So I can use cosine to find x. So cosine of 50 is equal to x over 5, and sine of 50 is going to be equal to y over 5. And so I can multiply both sides by 5. Calculator, make sure you're in degree mode. Cosine of 50 is going to be, cosine 50 times 5 is going to be 3.2. And then for y, sine of 50 times 5 is going to be 3.83. So that rounds to 3.8. So if I'm rounding to the nearest tenth, the coordinates of this point are going to be 3.2, because that's my x direction. That's how much I'm going to the right. 3.2, comma 3.8. So if my x or y value had been bigger than 5, that would be an issue, because the hypotenuse always has to be the longest side. So we're good.